On this worksheet, we're going to go through a few different types of problems that require us to apply LeChatelier's principle to a reaction in equilibrium. So the first problem, we're going to be looking at this particular reaction, and it tells us that the reaction is endothermic. If a reaction is endothermic, that means that heat is being added, and in terms of LeChatelier's principle, it's really helpful to think about heat as being a reactant for an endothermic reaction. If we had an exothermic reaction, it would be really helpful for us to think of heat as being a product of the reaction. So the first question is asking what will happen to the amount of NO, so let me just highlight that. What will happen to the amount of NO if the temperature is raised? So if the temperature is raised, that means we're going to be increasing the heat. Increasing anything on the left-hand side of the reaction arrow causes the position of equilibrium to shift away from that increase. It's going to cause it to shift to the left. So the position of equilibrium will shift to the left, and when it shifts to the left, everything on the left-hand side will decrease and everything on the right-hand side will increase. And since we're focusing on NO, that means that the amount of NO is going to decrease. So will the heat, so will the H2O, they will decrease, and then the NH3 and the O2 will increase. Second question is asking what will happen to the amount of NO if H2O is removed. So here we want to consider if we remove H2O, so I'm just going to put a little down arrow, meaning that it's being decreased. If we remove anything from the left-hand side, the system will shift the position of equilibrium to the left to try to put back that thing that was lost. So removing any one of these substances at all is going to cause the position of equilibrium to shift in the left direction to increase whatever was removed. And it wants to know what's going to happen to the amount of NO. Well, since the position of equilibrium is shifting to the left, this is going to cause the amount of NO to increase. Next question asks us what will happen to the amount of NO if O2 is added. So if we increase the amount of O2, if we increase the amount of anything on the right-hand side, the position of equilibrium is going to shift to the left to try to take away whatever we increased. So if the position of equilibrium is shifting to the left, that means that we're going to increase the amount of everything on this side. The amount of NO is going to increase. And the last question asks what will happen to the amount of NO if the volume of the container is increased. So this, if we're talking about changing the volume, also talking about changing the pressure, this only applies to the substances that are in the gas phase, which all of our reactants and products are in the gas phase in this situation. So if the volume of the container is increased, if we have an increase in volume, that is going to cause the pressure of everything to decrease. Just by the principles of gases, if you increase the volume, it decreases the pressure of the gases, or vice versa. If you decrease the volume, this causes an increase to the pressure. If the pressure of our system decreases, this causes the position of equilibrium to shift to the side with the most gas molecules, because it's trying to put that pressure back. It's trying to restore the pressure. So it wants to shift over to the side that has a lot of gas molecules. It's going to be really crowded and it's going to increase the pressure. So we have to figure out which side has the most gas molecules. The left-hand side has 10 gas molecules, 4 plus 6, and the right-hand side has 9 gas molecules, 4 plus 5. So we're going to be shifting to the side that has the most gas molecules. That means we're shifting to the left. And the NO is on the left, so that means that the NO will increase. Here is another problem. This one's going to have slightly different questions. Here's our reaction in equilibrium, and this is asking us about the rates of the reaction. What is the rate of the reverse reaction? Well, the reaction is in equilibrium, and when we're in equilibrium, the rate of the forward reaction is exactly equal to the rate of the backwards reaction. So looking at our choices here, the best answer is C. The rate of the reaction is something greater than 0, meaning that it's actually happening, and it is equal to the forward rate. That's key. Now it's telling us that we've added 114 millimoles of this guy right here. What is the rate of the reverse reaction immediately after it's added? So when we add this substance, when we add anything, the system is not in equilibrium anymore because we have stressed it out, and it's going to respond by trying to minimize that stress and put itself back into equilibrium. So we want to first think about LeChatelier's principle. If we are increasing this product by 114 millimoles, what's this going to do to the position of equilibrium? Increasing the amount of anything on the left-hand side is going to cause the position of equilibrium to shift to the left. And when we say the position of equilibrium shifts to the left, that means that the reaction in the backwards direction is going to work really hard for a while to try to counteract that stress that we added. So immediately after this has been added, the backwards reaction is going to be working harder, moving faster than the forward reaction. So the best answer here is going to be D, greater than the forward rate. The backwards reaction is moving faster and greater than the forward rate, and that rate will continue until the system is back in equilibrium again. Let's take a look at the next page. After the system returns to equilibrium, what's the rate of the reverse reaction? Well, whenever it's in equilibrium, the forward and the reverse reactions have the same rate. How much more of this product is in the flask when the system reaches equilibrium? How much more? So we added 114 millimoles, and it responded by using up some of that 114 millimoles, but not all of it. So always these types of questions, some, but less than whatever it was that we added.